Okay, good morning all. Welcome or afternoon. Welcome to this MasterShip webinar. The subject is a 3D model and what's next. So we will tell about 3 challenges or problems that you can encounter after you have established the 3D model. We do this with the 2 of us. So next to me is Tufail Shahzad. He works at our company as an innovation manager. And with myself, my name is Gijs from Beek. I work here as a project manager. If you have any questions during the webinar, then on the top right of your dialogue, you have a Q&A window, and there you can ask your questions during the webinar. Webinar will take about 40 minutes. First Tufail will tell us something about the problems, and then I will go more into the causes of the problems and into the solutions. And by the end of the webinar, we have a short demo that will take about 15 minutes. All your questions, we will discuss them at the end of the webinar or maybe during the webinar, depending on the question. So for now, I'm going to give the word to my colleague, Tufail.
Thanks, Gijs. Good morning and good afternoon, evening, depending on the time zone you are having. We welcome you to the MasterShip webinar. And as Gijs has said much of it, so today's topic is 3D model and what next. So the 3D model definition is different from people to people and wherever you are involved during the process. So a decade or 2 decades ago, a 3D construction model is kind of a full 3D model with all the things, no mistake, no collisions. That's what we call. As of C, these days today, it should include all the integration and other discipline and the systems. So it's getting more complex and complex these days. So then I think after this is it the 3D model enough for the production and for the construction of a ship? So the next thing we go is to see what is a production design and how things are added in here. So I had like highlighted 10, 12 things, and I go one by one. We call it in the production design. So the very first is section division. This thing is mostly happen for the big ship. And the question comes, what is a big ship? So when the ship is going to build in sections at different places, it's nice to do this during the detailed design. But most of the shipyards prefer to do it during the production design because they do not know who is going to build and what is the yard capacity and so on and so on. The next comes with the hull expansion and shipping molds. It's again nice to do it during the detailed design, so a lot of information can be added. Then it comes to the building molds. For a better fit of the bottom plate or keel, you have mostly seen a lot of molds at the shop floor. Then we go with the marking lines and text. It comes with the, speaks for itself. What does they do? So for bending, for folding, and so on. Then we came with the parts. What kind of information we have to have for the parts, what kind of things we need to mention on the cutted parts, so it went fine. Welding info. Now we can add a few of the details on the edges of the parts, so where it has to weld. Goes same for the chamfering, green materials, and one of my favorite comes with the building sequence. So building sequence is usually very pretty practical to do it to, so it's depending on the yard capacity, what kind of sequence they are going to follow. So it's always nice to provide them, okay, you can start with this building sequence, so they can allocate the yard capacity in a very right manners. Then it comes with the parts and stiffener reports. That's standard things. NC is also nesting parts and stiffener, last but not least with the cutting codes. So after the 3D model, so these are the things that are probably needed for the production design, etc. And these things are, being very honest, are sometimes very complex and very simple. So for today, we have highlighted 3 causes, 3 challenges we are facing, and then we see it's very practical to highlight a few of them. And as you can see, one is avoiding rework caused by collisions. It's also mostly caused by miscommunication. Miscommunication, I think, for the production or for any engineering work is very preliminary to happen. So we can talk about days and days, I think, but today we are going to talk about collisions mostly. Next one is limited search for parts. So that also a lot of time, if many of you I see are from shipyards having yard experience, so how hard and how complex it can be to find the right parts, and sometimes you simply lose it. Another thing comes with the workshop information. So yeah, working in a design office, you have a kind of a very beautiful 3D model and some fancy drawings. But if you pay a visit to a yard and then you see all the 2D drawings hanging somewhere, and the workshop information is usually not very much sync with the design office. So we see these 3 challenges. And as Gijs explained, I'm going to highlight the problems and then the cause and how I can solve it. My colleague Gijs will counter. Before starting our problems, and then this is a very nice example. We have it in house. We call it 10x rules. So what it says speaks for itself, I think. So finding the problems at the very early stage can cost less, 10 times less, and during the production and the other design. So we call it to find as much as problems at the preventing stage. So preventing stage, we usually call it a kind of a kickoff. Do it with the client, discuss the problem he has, discuss the time of things he is preferring to do, so we can consider them during the basic and detailed design. Let's imagine you find a problem during the production design. Okay, what are you going to do? You are going to do almost a reverse engineering. You're going to fix it, and then it has to be changed in the detail and the basic design, and all the information is at different places, different desks, the other disciplines. The drawing has to go in here and there. It's a lot of headache and a lot of problems. I don't want to say, but just imagine you find a problem at shop floor. Then it's very much costly. It costs some delays, and then you have to fix it. So cost of rework, that's our first things to do. And then if I have the second slide? Okay. So the problems rework cost. During a lot of research study has done for this purpose. And as we can see, a lot of other engineering disciplines are also struggling with it. So study shows 8 to 12% of a total engineering project is actually due to the cost of rework. So this is affecting a lot, and I think it's up to Gijs to see how he sees it, what can be the cause, and what solution you think of it.
Yes, indeed, Tufail. Thank you very much for this introduction. So we have identified a few causes for the happening of collisions. One is a lack of transparency between the different disciplines or the different subcontractors. And one is miscommunication either between subcontractors or between the draftsmen or project managers or etc. So there are in fact 2 types of collisions. The first type of collision is a collision between the different disciplines. So for example, the piping which is crossing a bulkhead, that's possible. And that's a typical example where a lack of transparency is the cause. So the subcontractors did not have a clear understanding of who is claiming which space. And the second type of collision is when 2 construction elements collide each other. So for example, when a continuous stringer is going through also a bulkhead, for example. And that typically happens when you have a miscommunication. So for example, two draftsmen working in the same section on adjacent drawings, but they are not aware. So the one thought, oh, this stringer is continuous, but the other draftsman thought, oh, the bulkhead is continuous. It's very easy to happen, and that also happens in practice. And again, so it's not a big problem if you encounter this in the drawing office, but as Tufail said, it is a big problem when you encounter it in the workshop. So we have two solutions for this as well. First, maybe this is quite nice to give you a bit of systematic overview of what is happening, and then also how those solutions apply to this. So as I already said, if you look at this diagram and you look from left to right, then you see a better communication contributes to less collisions. And if you have less collisions, then eventually you will have less costs. So the communication between the different parties and the transparency between the different parties, that's what we want to improve. So we have two solutions, namely the space claim. This will prevent collisions. And then we have a second best, and that is the collision checks. And that is, in fact, after the fact, but still in the drawing office. So here you see the space claim that improves the communication and the transparency between the different parties. And how does it work? We have in the space claim, in this image, you see three different disciplines. So on the top right corner, you see the assumptions that the construction builder made about the space that he needs. Then you see the assumptions that the piping and equipment expert made about the space that he needs. And on the left, lower left corner, you see the assumptions that the interior builder made about the space that he needs. So in fact, the space claim is a summary and a 3D visualization of the assumption that each party makes. And then you can combine it into one model. And if you do not do this, then for sure those assumptions will conflict with each other. So if you do not put this in a 3D model together, you sure have an overlap of the different disciplines. And when there is overlap, then you will get collisions in the end. So when you do this properly at the early design stages, you will reduce the amount of collisions between the different disciplines that you will get. And you will significantly increase your lead time because all the different disciplines can start at the same time. One challenge is here to not make your space claim too big, but also not too small. So say, for example, the construction builder makes his space claim too big, then your interior will be, in the end, a little too small. And for example, in a yacht, as you see here, the interior is, of course, the part that you want to maximize. And then finally, it's, of course, important that all the different parties stick to this space claim. And if they make a change in their assumptions, so in their claimed space, then they should contact the different parties and then discuss again if that's possible to make your space claim bigger or smaller. So, and then the second solution was the collision checks, which is in fact after the collisions are made, and as much as you try to prevent them, there always will be collisions in your drawing. So we should check them. And we are going to show that in the demo that we are going to give later on. So that will be in a few minutes. This is not the only problem that we can encounter, is it, Tufail?
Really not. So let's proceed with the second one, I assume. Yeah, limited search time for parts. As you can see, let's imagine you're building a boat. Everything is done. You order something from the cutting company send you a big pallets, and then just imagine how the workers are going to find the parts according to their sequence and so on and so on. I have a very recent experience of when one of our engineer actually visiting a yard where the board was going to build, and she was shocked to report that almost half of the workers were spending at least 1 hour a day on finding parts. So 1 hour a day, that's almost 1 out of 8, 12.5%. That's a lot. And then just imagine, yeah, let's say they're not spending every hour of a day on finding parts. So we make a just rough estimate of 8% of labor cost. That can cause a lot of issues if we go with this, I think. So let's go to Gijs and then see what kind of cause it has and what kind of solution we can provide to them.
Okay, Tufail, thank you very much for the introduction again. Yeah, so it sounds maybe even a little stupid, but the cause of parts or the search time is simply that the parts are hard to find. Sounds very simple, but it still goes quite often wrong at your workshop. So why are the parts hard to find? Well, simply because there is a lack of information. So again, the diagram from left to right, if you have if you have a high quality of logistic information on your parts, then you can sort your parts in a very clear and organized way. And if you have all those organized stacks of your parts, it's easy to find your parts. And if it's easy to find your parts, you will have less costs wasted on searching of parts. And if you do not have good quality, well, I think you can already think of it. It will be one big mess. You cannot make organized stacks if you do not have the right information. And then you have one big mess, and somebody just have to drag out a part and another part to finally find the part that he wants. So what is the solution here? Again, simply provide the right information. And so that's what we are going to zoom in. If we have that on the right place, we can make the organized stacks, etc. And then there's one added benefit of having good quality logistic information. And that is that you can also improve your nesting efficiency. You can improve your nesting efficiency by, for example, doing multiple sections in one plate. And so for, say, you have, you nest each section one by one. Then you have more waste material than when you nest all the sections all together. And if you have the right information on your parts, you can in fact do that. Then you can nest it all together and then take out the parts that belong to the according section. So yeah, that also in turn will bring down the costs for your material. Let's see, what else do we have? Yeah, so in MasterShip, we have a command called ship text set text in plate. And this makes it quite easy to provide the right information right away. So what you see here is a printed or a nested plate. And if you see this, you still have no clue what is in the plate. So what we do, we have a command called ship set text in plate. And if you use it, then you see, then you get in yellow in this case, the information that we need. So let's look at this part. Here we get the part ID, including the frame number, so 103. So that's the first thing of logistic information. Then we get the section number. That's the second part of logistic information. And then we get also the subsection here to sort by. And if we look, for example, here at the hull plate, we see also that it needs to be shaped. So that's also part of the logistic information. So this is maybe shaped, but we can also say that another part needs to be painted, for example, and that's not only organizing your parts, but that's also a matter of logistic flow. So having this available is helpful either to you or to the cutting company, because you can also ask, hey, if the cutting company can do the organization of the stacks. And yeah, so if you have this information, say we as shipbuilders can maybe quickly identify that this is a hull plate. But if you do not look careful, you could also say it's a deck plate, for example. But a cutting company will for sure not know what it is. So having this information is clear to you, but also to a cutting company. So you can have it delivered on your shipyard in organized stacks already. But then there's one problem left, because, for example, if you look here at this section in the workshop, you see that the parts are divided by section or by subsection or by frame, I don't know, but the plates are stacked on top of each other. So this information that we have here, for example, on the bow thruster, is in the middle of the plate, but now the other plates are stacked on top of it, so we do not see it anymore. So what can we do about it? Well, we can, for example, put the part ID here in the corners of the plate. And that is a very, again, easy solution to improve your logistic process. Let's see, I think this is this covers the solution for the logistic information. So we have 2 problems tackled, but we still have 1 problem left, or not, Tufail?
Yes. So our next problem is almost a follow-up to the solution you proposed.
Yeah.
So we have a kind of, fancy softwares, a lot of information, detailed 3D construction model, but still, what's happening wrong? What's happening at the shop floor, workshop information, it's usually very unclear. So whatever you are seeing during your design office, it's very detailed, like you are showing the nesting, etc. It's very clear. But again, what goes wrong when it goes to the shop floor? If you, I assume many of us has a chance to visit, as you see, it's still very outdated, very unclear information. Still, the 2D drawings are hanging somewhere, and some changes are happening, but the drawing it's on their way, but they're still happen. So it's still very outdated information, and that's usually lead us to the costs. So summarizing up with this, this is again, I think we have the shipbuilding industry is tackling a lot in the past decades, that how we can make it simple and very easy for the shop floor workers. So I have a very nice example we faced recently. So we were working on a very nice project that was an inland freight vessel. So here you can see, it was damaged, unfortunately, and fortunately it was come to us to fix it. So you can see a long stringer is damaged and we have to replace it. It's pretty straightforward. So then I think we have made a very simple drawing. Okay, that explains like this. So then it has to be bended at 90 degree and then we added. So everything looks simple. Why I'm showing this? So it went wrong. It went wrong because the shipyard was also subcontracting this information, this bending to another company. And what they did is instead of bending on the other side, they bended on the like of this side. So MasterShip has a kind of a terminology, a decoding list which we provide. So the abbreviation, the terminology we are using. So we indicated here the OS 90 degrees. So you have to bend it on the other side, but they didn't find it out. And it was very costly. We were expecting to show an image of the wrong bending one, but couldn't find it. But yeah, that's that. So these are the very small things that can go wrong. So we have the problem here, and then there are plenty of it. I think we can figure it out, but I just highlighted the very recent one. So let's go to Gijs to see how can we avoid, what are the main cause of it. I think goes to you.
All right. Yeah, one of the problems is that the conventional workshop drawings are not used very often, and that's because they are not always easy to understand. Sometimes you have to use maybe 5 to 10 minutes before you even understand this 2D drawing that you have. And then second, the workshop drawings are very often not complete. And that's simply because of the fact that workshop drawings are in 2D, while the 3D information can be very relevant. Maybe you want to see the longitudinal girder crossing this transverse floor or bulkhead. But that simply is not in your 2D drawing, so they are incomplete as well. And also, you cannot provide all the information in your drawing because it will sort of explode because of all of the information in it, and it will sure make it not more clear. So if you look at the system diagram, I already said it, the clarity of the workshop drawings or the completeness of the workshop drawings, the better you do it, the less mistakes you will get in the production. And if you have less mistakes, then you will have less costs of rework. So we have to improve the clarity of the workshop drawings and the completeness of the workshop drawings for them to be actually used. So we have one solution for this, and this is something that we call the workshop assistant. And the workshop assistant is in fact just the 3D model in your workshop. And that maybe sounds a bit complex to you. So no, not per se complex, but I can imagine that you have your doubts about it. How is somebody going to use a 3D model? So a welder, how is somebody going to use a 3D model in the workshop? Well, the challenge is here to make it as easy as possible for a welder. So if he sees the 3D model, he can instantly know what is going on and see it. He does not have to be an expert in that software. Nobody has to be. That was one of the requirements when we set up the workshop assistant. And the beauty of it is that it works. So some of our clients already use it, and we get good feedback on it. Some of our clients already stopped making paper workshop drawings, so the conventional workshop drawings, for about 90%. They make only 20% of the workshop drawings, or 10% of the workshop drawings. And mainly it is used. So they see a lot of people in the workshop standing in front of the 3D model, and they can orbit around, they can click on a part, see what extra information is there. And that seems to be very helpful. Then there is one added benefit of the workshop assistant, and that it is that it also will have a direct effect on bringing your costs down. Maybe it might be minor, but still, the draftsmen do not have to make the 2D workshop drawings anymore. So that alone saves you some time. And then finally, there is even a third benefit of the workshop assistant, and that is that it improves the communication in the early or maybe some progressed design stages. So this was the system diagram that we first used for the space claim and the collision checks. And then we said, well, the communication and transparency between different parties is very important to prevent collisions. So this workshop drawing does not only, or the workshop assistant is not only helpful for the workshop, but it's also very helpful for the drawing office. And it's also a means to improve the communication between the draftsman and the project manager. So it enhances the communication and in fact will remove or not remove, will encounter some collisions and also have a improved effect on the costs. So we have 3 benefits of the Workshop Assistant, and because of this, we would like to give you a short demo about this Workshop Assistant. So yeah, let's take a look. This will take about 10 minutes or so. I'll close this. This is MasterShip, and this is what we call the Workshop Assistant. So what is the Workshop Assistant? The Workshop Assistant is a plugin from MasterShip into Navisworks. And using this plugin, we get all the MasterShip information from your construction drawings into your 3D model. So this is the thing that we can actually place in the workshop or at the drawing office. And the advantage of this over regular MasterShip is that this is very user-friendly and very easy to use. Anyone will understand it in minutes. So what we see here is the 3D model of a Explorer vessel. This vessel is about 100 meters long and has a beam of 18 meters. We use this model for internal purposes, so for training ends and etc. So if we take a look at it, we can look a little bit around. You can see here on the left, we have the selection tree, as we call it. And if you click on it, the according section will be highlighted in blue. So for example, if I click here, then you see this section, etc., etc., etc. And you can also zoom into this section. So I click hide and selected, and then we look only at this section. It can be quite helpful, but we can also look only at the equipment, for example. So we look at the propeller and the helicopter, the main engine, and whatnot. And then we hide the rest, and then we have a look only at the equipment in the ship. So that's a helpful tool, depending on. So this might be used in the early design stages for the space claim, but also for the later collision checks. And if you use this model in your workshop, you typically want to look at one section. So let's take this section from the bow. So this is what you typically would place in the workshop. So in this workshop, we are going to work on only one section. So this is what we are going to look at. So now if we look around, you can orbit a little or do things. And if you click apart, so here I click now the deck plate, and you already see the MasterShip information. So here you see now, for example, I hope you can see it via the stream. But here on the right, you can see the part identification number, the section number, the thickness, the material, the drawing from which it originates. But there's more information that you can get. So in fact, all the information which is stored in the MasterShip database, so each part has a lot of meta information in it. You can get, if you like, all this information into your Workshop Assistant. So you can also get, for example, information about the treatment that this part needs, or who did make this part, which draftsman did it make. So if you have a question about it, then you can go to the draftsman. Hey, why did you think of this? Why did you model it in this way? And that can be very convenient. So this is now not very transparent yet because we cannot really look into it. So what we can do, we can maybe hide a few deck plates, and then we can look into the model a little bit. But what is maybe better is if we really look through it, and we do that with the sectioning. And this is now an example of a box. We can also do a plane. And I can now click this surface. And then I can really move through the model. So I can now look into those tanks here on the side. I can pull it further down. I can look at the floor or the bottom with the floors. And I can do this for only this section, but we can also do it for the total ship. So now we look at the complete bottom of the ship. And then again, you can go up and down and back and forth. So you can do this in all directions. You can also do a box view. It can also be quite helpful. So here we have a box view, and we can make this box either bigger or smaller. So now we have the box a little bit bigger. And then if you move it, you can go through the model. And what we like to do is to make it small. So maybe, for example, about 1 meter. And then you really have a slice of the 3D model, and then you can move through it. So if I now go forth, I really get this intersection of my model. And where am I now in my model? So if I click on, for example, this part, then I see, okay, here on the right, we again have the data of that part, and this says, this is frame 97. So now I know, okay, this is frame 97. I know where I am in my model. And then we can just take a good look. So this is, those are this is, I think, the workshop assistant in a nutshell. This is how we can use it either in the drawing office or in the workshop. So this box view is something that you will typically use in the drawing office and not per se on the shop floor. But if you use it on the shop floor, you can use the full model with only the section. So then you go this, and then you get your parts. So one thing I want to show that is maybe nice, because all the information from the MasterShip database is back into this model. You can also look up parts very quickly. So we can, for example, go here, find the items of this section 228. And then we can say we only want to see the parts from, you can do anything. So with a thickness of equal to 10 millimeters, for example. And then we do find all. And now all the parts with a thickness of 10 millimeter are now highlighted in blue. We can do that for any, so it's not only thickness, you can do also maybe the drawing path or the ID or the type, or maybe even the author of the drawing, etc., etc. So those are very nice links back to the MasterShip database. And then finally, I owe you the demonstration of the collision checks. So what we have with the collision checks, it was to prevent, to identify the collisions in your 3D model, to prevent them from having the actual collisions in your workshop. So this is also, again, something that we use in the drawing office. So therefore, this functionality, the clash detective, we have. And let me reset this to, I snap it out better. Reset all. So we can make a test, and then we can say, oh, we want to compare this selection, section A, we want to compare it to the selection on the right. So we can say, for example, we want to see the collisions between section 228 and the firefighting system, for example. If we then run the test, we get all the collisions between the piping of the firefighting system and the solids of the 3D construction model of section 228. But you can also look for internal collisions in section 228. So that's, for example, a bracket intersecting the hull, or a stringer going through a bulkhead. things like that. So that's what we are going to do. We are going to look at section 228 again, and then self-intersecting, and then we give it a tolerance of 10 millimeters in this case. So you can also say we make a tolerance of 1 millimeter, 10 or 20 or whatever. We go for 10 millimeters tolerance, and then we run the test, and here you get 8 clashes in section 228. And then here you see the clash number, and then if you click on it, you can really see it. I put this on the right side of the screen. I make this a little bit bigger and this a little bit smaller. So here we see our first clash. In red, we see a stiffener, and in green, we see a hull plate, I suppose. Yeah. And you see how they clash. So this is a clash of 38 millimeters, which is quite significant. You can orbit around a bit, and there you see it. This stiffener is going through the hull plate. So that is simply an engineering mistake. Then we have a few other clashes. This is bracket, also on the hull plate. Another bracket on the hull plate. And another bracket. So brackets seem to have been a problem in this in this drawing, but as you see, they are just going at the hull thickness. So it might be, this is probably just a mistake that an engineer made, but this will solve itself in the actual production. And we can say, okay, all those clashes of the brackets, we approve them. It's no problem. It's fine as they are. But if we say this is a problem, then we can say, okay, this is an active clash, and we can assign it to somebody, and that somebody can then fix that mistake. But for now, we say this is approved. We get all green dashes, and that's very nice. But then we have 2 clashes left. So this one from the stiffener, and the second is back the same, but then on the port side of the ship. So those clashes are, let's say, they are not acceptable. So we have to make them active, and we are going to assign this clash to the engineer, Gijs from Beek. And then we give it a note. This is a clash. Check the length of the stiffening. Then we do OK, and then we get the status, and then we can update this in our 3D MasterShip model. Then we go to the MasterShip model. So this is the same section, but then made and viewed in MasterShip. And we already know where the clash is. It was on the bottom. And let's zoom in, and there you see it. So here you see that stiffener going through the hull plate. That's not what we want. So we are going to fix it. And this is now the drawing office. So we are now in the drawing office. And this is, for example, either the workshop or the overview that the project manager gets. So this is now back in the drawing office. So I'm now a draftsman, and I'm going to look at this part. This is the one which is going through the hull. We can now decide to make this stiffener shorter, or we just move it. I'm going to move it up by 50 millimeters. And I think it was also clashing on this side. Let's adjust it. Also by 50 millimeters up. So now we have no clash anymore. So I fixed the clash in my 3D MasterShip model. And here in the assembly, it will be updated. I reload this frame, yes. And you see it's now gone. So this is now still the drawing office. But we want to see it in in the workshop. So assume we are now in the workshop and the collision is fixed. We refresh our model. And this can take a few seconds. So only the relevant drawings are updated. Yep. Only the relevant are updated. And if we now look at our clash again, so here this was the clash, and this was also the clash. We do our test again. So we rerun the test, and there we see it. Clash 1 and Clash 2 are also both resolved. So that's automatically identified. We can take a look at it, but we can also just say, hey, they are indeed resolved. So we do not see it poking through the hull plate anymore. So we are happy. So this was now an example of a collision fix. But you can also do this with revisions. And that's very helpful if you are in the workshop. So you say, oh, I want to give this slightly a different angle, or I want to adjust the end details of my stiffeners, I don't know. You can update it in your MasterShip model, and within seconds, it's updated in the 3D model from the workshop as well. And that will prevent rework because your workshop drawing is automatically updated. So I think we have sort of seen it all for the workshop assistant, or not all, but there is of course much more. But we are a little bit short on time. So I think it's good to wrap up and go back to our PowerPoint presentation for a final conclusion. And then if there is some time left, we can look at some questions. So I think I'm going to give the word back to you, Tufail.
Okay. So thanks for the demo. I think that covers almost most of the conclusion itself. So explaining it in a nutshell, I think for us, the information is leading and the communication is leading. So these all things are very much necessary to find out. So a 3D model, when we say is far from ready from production, so there are still some things to do. So providing the right information saves a lot of time and money. That's we have seen that if everything is clear upfront, then how much time we can save during it. Take out mistakes as early as possible. So that's almost covering our 10x rules. So when we can do the preventing at the very early stage, then it is definitely, and doing it properly requires the right tools. And MasterShip strategy has always been to make it simple, as easy as possible, because when you are sitting in a design office, I think you can deal with all the complexities of a software with some discipline and so on and so on. But when it has to be on the shop floor, it has to be very simple for the people who are working, who are dealing it. They do not have to be very skilled in something, so they read the information as simple and as easy as possible. So these are almost the conclusion from ourselves, and I'm recalling it. So as an overview, in our MasterShip routines, day-to-day work, our 90% problems, 90% of the mistakes are done due to communications, not from the technical mistakes. So if we take care about these, have to sync, I think, the shop floor and the design office as much as possible. So 90% of the mistakes, I think, can be fixed with that formula. And 10% of the mistakes are technical mistakes, okay, clashes and so on and so on. So that's more or less for the conclusion, I think. And we proceed with the final. Yeah, so MasterShip webinars, I think, as I explained this, we are doing it to encounter now and then we receive some problems, some challenges from client, and also we figure out by ourselves. So we try to address them. So my question and our joint question from you is, which problem and challenges do you encounter? And if you want us to address that, how we fixing it or what we are doing it, write us. You can see the emails at the end, and then we will get back to you. I see some questions also.
Yes.
But I think we are a bit of time.
Yeah, I think we are indeed a bit short on time, but I think there's one question that we can answer now, because that's quite relevant to the demo and maybe also to the other attendees. The question is from Dingo, and Dingo asked, is the presented info stored in the model or added manually in the nesting? And I think Dingo is referring to, let me get a little bit back to the nesting here. So what I showed here was how we get the logistic information into the nested plate. And then Dingo asked, is this information added manually to the nesting, or does it come from the model itself? Well, this information comes directly from the model itself. So this is literally added with the press of a button, and all the information that you see here on the parts is extracted from the MasterShip database, and then using this command, it's automatically put into the parts. So thank you for your validation, Dingo. Then we see that we have a few other questions from clients as well. They are a little bit detailed, as I see now, and maybe for the sake of time, it's good to come back to you personally about it. So thanks again, everyone, for attending our webinar, and going in the wrong direction. Thank you all for attending the webinar, and we would like to see you in the next one. I wish you all a very good day.
Great. Good.